Hello, my name is Michał Śmiałek, and I would like to tell you about BalticLSC, a new platform for low-code, large-scale computations. Let's start with some background. I assume that you might be an innovator that wants to develop a new product or service. For example, you might want to develop a new catamaran yacht or a new virus vaccine, or perhaps a new airport security system or weather forecasting service. You then want to monetize it. That means you want to earn some money out of it. You develop the product or service and then you produce it or run it somewhere in the internet. Here we will concentrate on the development stage and especially these activities that need a lot of computations. For example, you might need to calculate the yacht's hull aerodynamics or compute DNA sequences, or maybe you want to train a neural network or test your weather forecasting algorithm. So how do you normally approach the problem of computations? You can use a ready computation application and run it on your computer, obviously, which usually takes a significant amount of time and makes it quite slow in order to monetize your solution. You can also use some cloud service that might make the computations faster, but at an additional cost, and you need to do all the installations and other technical stuff yourself. And what if there's no suitable application? Well, you need to write it yourself or by hiring some programmers. This adds a lot of additional time. You need to analyze and design the application and then write code and test it. And only after that you can run it and obtain your results. So how do you do it using BalticLSC? First, you obviously need to formulate your computation problem. Second, you can shop or search through our App Store for an appropriate application. Third, you specify where your data is. And finally, you run the application. All this is done through our integrated web interface. This way, you can turn your ideas into ready product or service much faster than before. If there's no ready app, you can search for smaller computation modules and build your own app from these modules. Then you can obviously run it as a regular app. Note that you can build your app in a user-friendly graphical editor, and you don't need to code in Java, Python, C#, or any other such language. Only when you cannot find any suitable module, you need to write it yourself. However, our plan is to offer an extensive library of ready modules. There are 5 components of the BalticLSC platform. First, we have the application store, where you can find your apps and modules. Second, we have the computation cockpit, where you can run your computations. Third, we have the data shelf, where you can tell us where your data is. Note that we do not store your data. Your data can be kept safely on some server that you can access. And finally, all this is complemented by the development shelf, where you can develop your apps using a graphical editor. So now let's take a look at the user interface of our platform. In the application store, you can select apps and add them to your computation cockpit. Then in the computation cockpit, you can find a list of your computation tasks. And here you can start and then manage execution of your applications. In the data shelf, you can define all your data sources. You define the input data sources, and also you tell us where you want your results to be sent. In the development shelf, you manage all the modules and apps that are created by you. This also includes creating and editing your applications. You use a graphical editor, and this involves a graphical language called the Computation Application Language, or CAL for short. Let's go now into some technical details, but just a little bit of these technical details, don't worry. The end user communicates with the BalticLSC through a web interface installed on our central server. This server is connected with a network of computation clusters distributed throughout Europe. The network can be easily extended with additional clusters, and we can connect clusters with different computation power, from big supercomputers to even small computation servers. Our main requirement for these clusters is that they can run standard operating software like Kubernetes or Docker Swarm. On top of this, we just need to install our small compact module that allows for communication with our central server. Now, you might wonder how to write an application in CAL. CAL is a visual, low-code language, and it is very simple. It uses just three types of elements. First, we have data pins that define data sources. Single data pins define single files. Multiple data pins define folders of files. And multiple token pins define sequences of files. Second, we have data flows that connect data pins. And finally, we have modules or module calls that run computations with the data specified through data pins. Here we have an example of a CAL application. The application takes two folders on the input. One folder contains video files and the other one audio files. The first module synchronizes these files from these two folders, for example, by matching their names, and then sends these files to the output pins. Then the second module, the mixer, mixes video with audio and produces some film. This is then sent to some output folder. Note that the app can process many video and audio pairs at once and mix them into many films. This means that these many files can be processed in parallel at the same time. So how this parallel processing can work in BalticLSC? Our main goal is to use several computation clusters at once to speed up your computations. The BalticLSC computation engine creates a task whenever the user wants to run an application with specific data. Of course, you and other users can run as many such tasks as you wish, and these tasks can be run at the same time. The tasks are divided into jobs that reflects the computation modules. And these jobs can be assigned to specific computation clusters. One cluster can process many jobs at the same time, like, for example, cluster B in this example. This all depends on the computation capacity of the given cluster. Finally, let's see how does BalticLSC work from the point of view of the end user. Note that the end users do not need to know most of the internals of the platform, but some issues are important to know. So, for example, you need to know that the computation engine is run on the main node, and this main node communicates with the computation clusters. You, as the end user, have to prepare your data and place it in some server that is safe for you and can be accessed from the BalticLSC system. And of course, you have to tell BalticLSC where your data is. Then you use the computation cockpit to run your application. Our engine distributes jobs to different clusters, And then the running modules, the modules that run on these different clusters, can take your data and process it. This data, after processing, can be shifted between various computation clusters depending on your application, of course. And finally, after all the computations are finished, the results are sent back to your data store. Okay, so with this final short technical overview, we conclude this presentation of the BalticLSC platform. If you would like to know more details, you can go to our website or send us an email. And obviously, we look forward to hear from you very soon. Thank you for your attention. Bye-bye.